Next, we'll take a closer look at the routing table. To see the routing table, we run the command show IP route. Okay, so running this command will show the routing table which the router used to route incoming packets to the router. Okay, then this will show you how to route the packet, what is the outgoing interface, or the next hop IP, okay, when the router receives a packet going to that particular destination network. Okay, let's take a closer look. Okay, a routing table consists of different entries. Okay, so let's look at for the directly connected entries. So directly connected networks are automatically added to the routing table when you configure the interface and you activate it using the no shut command. So the entry will contain the route source. Okay, so for every directly connected network, you will see a C, which is the directly connected network, and the L, which is the link IP address, the exact IP address. Okay. So this network, the destination network, okay, 172.16.1.0/24 is directly connected to this router and is connected to the gigabit interface 00. So this will be the outgoing interface. So what this means is that if this router receives a packet and the IP address, the destination IP address of the packet is in this network. Okay, for example, the destination IP address is 172.16.1.10. Okay, the destination IP address. Okay, and this IP address happens to be in this network. Then the router will forward it out through the G00 interface, which is connected to the 172.16.1.0/24 network. Okay, so this helps the router to make routing decision. Okay, because this network is directly connected, I will forward it out to the G00 interface. Okay, other routing source besides C will be your S for static route, D for your EIGRP, which we will learn in the subsequent chapter, O for OSPF, which we will also learn, and RIP that we learn in the current chapter. Okay, let's look at the remote network. Okay, in this example, we use the RIP as the routing source. So because we learned this through RIP, so R is first shown in the routing table, followed by the destination network. So this network is 172.16.4.0/28. So this will be the subnet mask. This tells the router, if the router receives a packet, okay, and the destination IP address of the packet happens to be inside this network, okay, then this route will be a match. The router will know how to process this packet. Okay, the next field, okay, which is contained in the square bracket, okay, it contains two fields, the administrative distance and the matrix. Okay, administrative distance indicates the trustworthiness of this routing source. Okay, so I learned this route through RIP. So for RIP, the administrative distance, okay, is 120. Okay, if I learn about this network through another routing source, for example OSPF, okay, and OSPF tell me that to go to this network, use another route. Because OSPF, the administrative distance is 110, I will remove this from the routing table and I will believe OSPF more, because OSPF, the trustworthiness is lower. So the lower the AD, the better. So if I learn the same route, okay, if I learn a route to go to the same network through EIGRP, okay, I will believe EIGRP, because EIGRP is the routing administrative distance is 90. Okay, so for static route, that means the administrator configure a static route and happen to go to the same network, okay, I will believe the administrator, because the static route administrative distance is 1. For directly connected network, administrative distance is 0, because it's directly connected, it's just next to me. Okay, so this indicates the trustworthiness of the route. Okay, the next number indicated in the matrix, in the square bracket, is called the matrix. Okay, matrix is the value assigned to reach the network. Okay, the lower the value, the better. Okay, this value is compared to the route that is learned through the same routing source. So for example, through RIP, I learned that I can go to this network, okay, through two methods. Okay, so for example, okay, to go to this 172.16.4.0 network, okay, there's two ways. Go to this way and go to this way. And I learned it through RIP. Okay, so to go to this way, the matrix, for example, is 2. To go to this way, the matrix is 3. It's 3 hop away. So because of this, this route is a preferred route and it will be entered into the routing table because the matrix is lower as compared to the other route. Okay, remember, matrix is compared between routes from the same routing source. Okay, if it's from different routing source, they don't compare matrix, they compare AD. They will use the routing source with the lower AD first. But if from the same routing source we learn about two routes, then I will use matrix to decide which route to use. Okay, the next field is called the next hop. Okay, next hop is where to send the packet if I receive a if I receive a packet going to this network. How should I send the packet? So this will be the next IP address I should send. So next hop belongs to your neighbor IP address. So for example, okay, if the destination network is over here, so if this router receives a packet going to this network, the next hop will be the IP address of this router, this interface. So this will be my next hop. Okay, so that will be the next hop. Okay, the timestamp is how long have we learned about this route. So the timestamp should be as long as possible. If the timestamp is very short, that means this route keep on appearing, disappearing. So if the route is stable, the timestamp should keep on increasing. So this should be a good, large value. Okay, and finally, outgoing interface is where should you send the packet out, which interface. So if this route appears in R1, so this will be the exit interface. We call it the exit interface. Okay, so remember, exit interface belongs to this router where this route appears. Next hop belongs to the neighbor interface that you should pass it to. Okay.